So we're going to move into connective tissue. We just finished epithelial tissue and that basement membrane and glands. Now we're going to move into connective tissue. So the first thing we want to talk about are the classes of connective tissue. Alright, so our four classes of connective tissue are connective tissue proper, cartilage, bone, and blood. So 2 B's, 2 C's, that's how you can remember it. So connective tissue proper, let's go in a little bit more. What do we have? We have some dense, regular connective tissue. We have dense, irregular connective tissue. And then we have loose or areolar connective tissue. So cartilage, he mentioned hyaline, cartilage, fibrocartilage, and then elastic cartilage, I think is his last one, and elastic. So this is one word, fibrocartilage versus elastic cartilage, and hyaline cartilage are 2 words. Bone, we have spongy and compact. We're doing a whole unit on that next, so don't stress about it too much. Okay, so these are our 4 classes. Now what we want to look at is, bone and blood don't sound very similar to me, and bone and cartilage don't sound very similar to me. So why is it that all these things are considered connective tissue? So we want to look at some similar things. There's 2 things. They have similar components called structural elements, which we'll get into, and they also come from the same embryonic origin. So let's get into these structural elements. What makes up connective tissue that makes it a connective tissue? Let me get some words up here. Alright, so when we're looking at these common things in connective tissues, these similarities in their structure, we have these structural elements. So the first one is this ground substance. This ground substance is made up of 2 things. So we've got this background fluid, and we also have proteoglycan. So these are different than glycoproteins. Glycoproteins were those things in the basal lamina, and in last unit we talked about cellular reception, but this is a proteoglycan. So we still have a protein, we still have a sugar, just a different orientation. So these proteoglycans look like that. That's a protein core, but these carbohydrate extensions coming off. So that's one proteoglycan. Let me draw another one. So what these carbohydrates are doing, these carbohydrate extensions, they're meshing. So they're kind of forming this, the basis of this matrix. And then you have all this fluid around. So that's your background fluid, along with your proteoglycans. And then we have these fibers. These fibers are just all around. And we had a few different types of fibers, things like elastic fibers, collagen fibers, reticular fibers. So elastic cartilage is going to have a lot of elastic fibers, just for an example. So fibers, different types. Elastic fibers, collagen fibers, and reticular fibers. Different types of cells. You might have a fibroblast if you're talking about making, producing some of these fibers, so fibroblasts. Or you might have a chondrocyte if you're trying to make cartilage. Chondrocyte. Or an osteoblast, that's a bone cell. Or osteocyte, we can just say that for now. Okay, so structural elements. This is what we got. Oh, I guess I should draw some cells in there. So here's our connective tissue structural elements. Ground substance, which is this fluid and these proteoglycans. These fibers running throughout the whole thing. Things like elastic and collagen and reticular fibers. And then these cells, these different types of fibroblasts, chondrocytes, osteocytes. If you look at the ground substance and the fibers within it, we have a name for that. So if you just get rid of the cells, but you just look at the ground substance, which is the background fluid and the proteoglycan, you look at all the fibers, that makes up, so I'll do ground substance plus fibers equals the extracellular matrix. So that's just the name that we give to the fluid, fibers, and proteoglycans. So this is one thing that makes all these connective tissues connective tissue, having these structural elements. Now, obviously in bone, you're not going to see background fluid. That fluid crystallizes, but when bones start forming, there's some fluid around. And then the other reason that they're grouped together is they all have the same embryonic origin. So we'll get into those different germ layers at the very end of this, but right now, we know that all these connective tissues come from the mesoderm. So the mesoderm is going to produce mesenchyme, and then these mesenchymal tissues are going to differentiate into your different connective tissues. That's one thing the mesoderm can go into is connective tissue. So germ layer, mesoderm. So that's connective tissue, connective tissue. Now let's look at muscles, because what we were looking at, we did epithelial first, and then we did connective. Now we're doing muscle, and then we'll finish with nervous. Now these get their own units by themselves, muscle and nervous, so we're just going to give some basic definitions for those.